Thank you, Ms. Wexton. The chair now recognizes Mr. Posey for 5 minutes.
Thank you, Madam Chair. When you talk to people who aren't familiar with history, and you mention the importance of our space program to the survival of our species, you get some chuckles and you even get some harassment. A lot of that diminished somewhat when we had that relatively small asteroid implode over Russia 1,000 miles from the nearest living person and injured 1,000 to 1,500 people. It did wake up some people to the possibilities. The Planetary Science Division of the Space Mission Directorate is responsible for the Planetary Defense Coordination Office, which searches for, characterizes, catalogs near-Earth objects that could collide with the Earth. NASA established a Planetary Defense Coordination Office in 2016 in response to the NASA Inspector General's report. And the Trump administration is calling for a significant increase in near-Earth orbit funding. Congress asked NASA to identify 90% of all hazardous near-Earth objects by 2020. NASA recently provided us a report that indicated they're not able to reach the goal in that time period, but that the National Science Foundation's large synoptic survey telescope, coupled with a space-based infrared mission, could accelerate the survey. And so, Mr. Zabukin, I just wonder if you can tell me if NASA is now ready to go and what the time outlook may be.
Thanks for the question. We're committed, of course, that to achieve that goal. We're not going to make it by 2020. I should have started a few years before, sorry. But no, I mean, look, I mean, we are, what we're focusing on are two things. First of all, we want to use any and all assets that are available, whether it's from the National Science Foundation or from our own missions, to look at the data that are there and include it into the very database that you're talking about. For example, the TESS mission that's out there in astrophysics is one of those sources that we're piping into that very analysis. The second one is through the increase by close to a factor of 3 of that particular budget line that I've led together with our team, we're enabled to actually do the very mission that you're talking about. In fact, we've started to invest in the technology, the sensor technology, to detect those very cold objects. And it's our expectation to go forward with that mission in the next few years as a budget which becomes available in that line.
Mr. Sykes, did you want to comment on that? You had the largest grin when we were talking about survival of the species.
Well, we do have the technology, and with the moving forward of the NEOCAM mission that provides the space-based infrared component. I mean, the limit to Earth-based observatories, and I'm a telescope jockey myself, is that you can only observe at night, and when you can only observe at night, that means that you can't see much. The interior towards the sun, or interior of the Earth's orbit towards the sun, and we can be hit by stuff from there too. So the NEOCAM mission is placed at Earth Sun L1, in between the sun and the Earth, closer to the Earth, and it's scanning tens of degrees, closer to the sun. So it captures well inside the orbit of Venus. So all the objects that are moving in there. And there's an interesting thing. I'm sorry. Please cut me off. That for instance, those Chelyabinsk-sized 20-meter type objects that exploded in the atmosphere over Russia. Well, about 5 times as many of those objects are hitting us as based from detecting flashes in the atmosphere and infrasound than are predicted by the asteroid population models from ground-based observatories. Why is that? Well, there is a possible answer, is that you could have a breakup of an interior asteroid interior to the orbit of the Earth, and we're getting fragments from that. But you wouldn't pick that up in a ground-based telescope, but you would with NEOCAM. So there's all kinds of having this combination of these ground-based sources in combination with NEOCAM is really going to put this to rest. Not by 2020, but probably within 5 years of its launch.
The longest silence I've ever heard in this committee is when the President's chief scientist, the NASA administrator, and the Secretary of the Air Force were asked in one of our committee hearings if a relatively small asteroid, the one that detonated over Russia, were headed for the Big Apple and we had a week's notice, which we wouldn't have, what would we do? That's the longest silence we ever heard in this committee. Thank you.